Hello students, today's our topic is three spin system like A3, A2X, A2B, AMX, etc. In order to understand, consider a simplest three spin system in NMR. It means it has consist the three equivalent proton, that is they will have the same value of chemical shift. An example of such system will be an isolated methyl group or three equivalent proton bonded to three carbon atom. For example, this is the first case CS3COO CS3. Here, this type of the system can be classified as A3 system because all the proton attached to that carbon atom are equivalent and they will appear as a singlet peak. Similarly, in the second example, here there are three proton are located on the benzene ring. All these three proton are chemically equivalent and they will give a single peak only. Hence, we term these type of the system of the three spin as a A3. A3 means three spin system which have the same chemical shift value. However, if any one of these three proton have a different chemical shift value and this chemical shift value is very large different from the other two proton, that is del nu upon J is more than 10, then such type of the system is known as the AX2 or A2X system. In this type of the system, there are two proton are chemically equivalent and one proton is different from them and their chemical shift value is very large different from each other such that they will always satisfy this condition, that is their chemical shift difference divided by their coupling constant will be more than 10. And such type of the NMR spectrum can be considered by the following example. At this carbon there are two proton, we can consider them X proton. Here there is only one proton, this is the A proton, then it can be termed as AX2 type system. This proton, both of these proton being chemically equivalent, will couple with this adjacent proton and give a doublet. And this proton A will couple with these two proton and give a triplet as per n plus 1 rule. So this is a system of AX2 type which have the 3 spin system. However, 2 spin have the same chemical shift value. In the next case, if one of the three equivalent proton is slightly different in chemical shift value relative to the other protons, that is del nu upon J is less than 10. In the above case, it was more than 10. However, if the difference and the ratio of J is less than 10, then we will term this type of the system AB2 or B2A type of the system, and such type of the spectra will give total 9 line. And here we have considered the example. Here both of these proton have the same chemical environment, they are chemically equivalent to each other and they will have the same chemical shift value. This is the second proton Ha, which is different from these two proton and will give the different chemical shift value. But because their chemical shift value are slightly different, it means we will term them AB2 system. If their chemical shift value will have been largely different from each other, then this system would have been AX2 type system. It means we will use the alphabet AX when the chemical shift value of the coupled proton are largely different from each other, and AB type of the notation when the chemical shift value of the two proton are nearly equal to each other. In the third case, we have considered the AMX type of the system. Here all the three proton are chemically non-equivalent, that is they have different value of the chemical shift. We have considered the example of furon 2 aldehyde or perfurel. Here we can see there are mainly three kind of the proton at the position 3, 4 and 5. This is the H3, 4, 5 and this is the CHO. We expect total 4 signal in its NMR spectrum in the following diagram. This is the signal at the 6.6 Dale value from the proton H4. This is from H3, this is from H5 and this is the singlet peak from the CHO. Here these three signal together constitute AMX type of the system. We are not considering this one. So we are considering only these three peaks, and these peaks if analyzed we can see the chemical shift value of H5 proton is highest, that is it will appear at low field relative to TMS, then the H3 which in turn have the higher chemical shift than the H4. And we can also explain the splitting pattern in this AMX type of the spectra. All these peaks are obtained as a doublet of doublets, that is each signal consists 4 peaks. If we will pay attention on these diagram, then we can see easily that all these signal are appear as a doublet of doublets. Here we will consider the first case of the coupling of the proton H4. H4 have the two adjacent neighbor H3 and H5. It can couple both of them. Both are the vicinal proton, and we can see it has the two coupling constant value. When it will couple with proton 3, it will have coupling constant 3.6, and if it will couple with proton 5, it will have coupling constant 1.8. It means when the proton H4 couple with proton H3, its signal will split into a doublet, and then this doublet will interact with these neighboring proton at the position H5, and doublet will result in splitting into a further doublet, that is doublet of doublets will obtain from the H4. We can also explain the similar pattern from that H3. H3 can couple with proton H4 and H5. This is a long range coupling which have value very low, about 1 Hertz value. Then first, its peak will split into a doublet by coupling with H4 followed by coupling with H5. Then it will also give a doublet of doublets. Similarly, we can explain the splitting pattern from the H5, but it is little bit complicated due to its interaction with the aldehydic group as well, which results the formation of the peaks of the equal spacing of about 1 Hertz, and it can only be explained by considering that this H5 proton is also coupling with this CHO aldehydic proton as well, along with these two coupling H5 H4 and H5 H3. This system is defined as the AMX type of the spectra. Thank you.